Just as we did for a one-sample t-test, let's now go through a full example of a two independent samples t-test. Let's say a researcher wants to test whether people on a new medication have headaches that last for a different amount of time on average than people not on the new medication. He has data from a sample of 14 people on the new medication and records the average headache time of this group as 34.5 minutes with a standard deviation of 5.6 minutes. He also has data from a sample of 13 people not on the new medication and records the average headache time of this group as 40.3 minutes with a standard deviation of 6.3 minutes. As usual, the first step in our hypothesis test is defining the research question of interest. In this case, we are examining the question, do people on a new medication have headaches that last for a different amount of time on average than people not on the new medication? Essentially, does the new medication have an effect on the amount of time headaches will last in people versus people not on the new medication? Our second step will be formulating our hypotheses. For this hypothesis test, I am only testing whether or not there is a difference between the two groups, so I am interested in a two-directional test. My null hypothesis will be mu1, which I am going to designate as the people on the new medication, minus mu2, or people not on the new medication, equals 0. I am essentially saying in the null hypothesis that there is no difference between the mean of the two groups. My alternative hypothesis will be mu1 minus mu2 is not equal to 0. My third step will be determining a decision rule and finding my test's associated degrees of freedom. Let's say I'm interested in testing using an alpha level of 0.05. To find my degrees of freedom, I will use my formula for degrees of freedom in a two independent samples t-test of n1 plus n2 minus 2. I know my sample size of my designated group 1, people from my sample on the new medication, is 14, plus my sample size of my designated group 2, or people from my sample not on the new medication, of 13, minus 2. So my degrees of freedom would be 14 plus 13 minus 2, which equals 25. Remember, if you are doing your tests in SPSS, SPSS will also calculate your degrees of freedom for you. My next step is to find the test statistic. If I had used SPSS to conduct my independent samples t-test using my example data comparing the average amount of time headaches last in people on a new medication and those not on the new medication, it would have given me a test statistic of t equals 2.53 and an associated two-tailed p-value of 0.018. Our fifth step is making a decision about the null hypothesis. Since our p-value of 0.018 is less than our chosen alpha level of 0.05, we would choose to reject the null hypothesis. Our test results would be considered statistically significant. Our last step in our hypothesis test will be interpreting our decision. Remember that we were testing whether the two groups appeared to come from populations with the same means. Since I rejected my null hypothesis, I can conclude that it does not appear that the two populations have the same mean, or people on the new medication do not appear to have the same average amount of time that headaches last than people not on the new medication. In other words, people on the new medication do appear to have a different average amount of time that headaches last than people not on the new medication. We can also construct a confidence interval for the difference between two unknown population means, similar to how we've done previously with one unknown population mean. Using the t-distribution when the population standard deviations are unknown, we can calculate an estimated range we are a certain % confident that the true difference in population means falls within. Based on your data, SPSS will calculate this given confidence interval using the t-distribution. Our interpretation will take a similar structure as before. Our interpretation will be we are a certain percent confident that the true difference between population means falls within this range. One thing to note when interpreting confidence intervals in this case is if the confidence interval includes the value of 0, in other words, spans both negative and positive values, then we would fail to reject the null in an associated hypothesis test testing at the same level of significance. Researchers will often look to the p-value from their test statistics as well as their confidence interval to help make determinations about associated hypothesis tests. If the confidence interval does not include the value of 0, in other words, does not span both negative and positive values, then we would reject the null in an associated hypothesis test testing at the same level of significance as we used in our confidence interval.